So Einstein Industries Ventures and a partner, we newly started sector-focused fund. We invest in companies that are space-enabled somehow, and we focus on the applications. And we're really excited about Constellr, which is a bit of a family and friends investment fund.
Now I can sit closer when you said you were really excited.
Indeed, yeah. An investment we've made last year. It's a bit early for us, but we tend to focus later stage. But nevertheless, we're really keen to get involved with you. So I would like to broadcast, showcase to all of us here why Constellr is a great place, and maybe starting with technology, because unlike what has been said, we're not a nature tech company. I think that's a new label for you guys.
It is a new label.
I prefer the deep tech or new space kind of.
Yeah, we have a lot of interfaces. We're using quantum algorithms,
works,
AI, climate tech, space tech, whatever works in the moment.
So maybe to enlighten the audience, start with technology and what it is. I mean, you will be launching, obviously, not obviously to me, but obviously you will be launching the first satellite that you've developed, and maybe explain a bit around what technology is about.
Can do. So the idea is there's already 1,000 satellites around this, thousands of satellites actually. And a lot of them are looking at the visual spectrum. So that part which the mobile phone you're using sees, you yourself are seeing. What we're doing is we're moving the paradigm and going beyond visual to look at parts of the spectrum which are yielding information which are important for food security, for example, and for human activity in general. So we're looking at the thermal infrared spectrum. So basically heat monitoring, if you like. And we are predominantly using that for agriculture. So Marco has rightfully said we're looking at the water problem. It's one of the problems we're looking at. Because what this gives you access to is, on the one hand side, gives you access to the water cycle. So how much water is needed, how much water is available, how much water is lost to the atmosphere. It gives you access to the energy cycle. So how fast are plants actually growing? Are we in this optimal range of growth? And it gives you also access, therefore, to the carbon cycle. Because whenever you grow something, you're effectively sequestering CO2 from the atmosphere into biomass above and below the ground. And so all of these three cycles are governed by temperature, and having access to highly granular temperature data on a daily basis allows you to optimize resources. This is the first step, and then obviously you can add chemical information. But what we're really striving towards is that on the technology side, creating something which we call the biophysical atlas, so creating a not just digital twin, but digital measured twin of the planet, which gives you the biophysical reality of the planet. What's the amount of water? What's the temperature? What's the nitrogen in the ground? Eventually, even looking at carbon at some point, but really looking at the chemical and the physical features of the planet, kind of a Google Earth on steroids, but not just nice, colorful pictures, which are useful, but proper measurements.
Yeah, great. And obviously, as I've been saying, you've been talking about the technology, and I mentioned we're investing in applications, so how does that fit together? So we are excited about what can be done with what you've been describing, the capabilities, so to say, technological capability. But maybe you can give a use case or so, that's what we're talking all the time anyways, a use case that illustrates to the audience what it is exactly, like maybe one specific case that you can, to the extent you can talk about.
Very happy to do that, and let me use that moment to also advertise why we've chosen you to work with us. Because there's a lot of upstream, and it's really important to enable space. But there's also the real value comes, and I don't want to be offensive against, for example, you, Daniel, you're doing a fantastic job. But the real value comes when you can create things in space which create data and insights, and you can translate these insights into, let's say, water savings, into reduction of fertilization, into whatever applications you're looking at. And what you're doing at Einstein is you're focusing predominantly on the downstream. That's what it's called, so all these applications. And that's the reason we decided, hey, let's work together, and it's working quite well so far.
So our thesis is like with the internet 20 years ago. Someone was putting the cables in the ground and losing money on it, and then people came and built applications and got rich. So we're thinking of the same. Like, it's people building infrastructure, and Constellr is obviously between infrastructure and applications, so that's why we're excited. But that's why I want to move the conversation onto applications as well, just to highlight that feature.
Sure, absolutely. So to give you a few applications, so just an idea, we are working with a very large machine producer to optimize seeding depth. What has this to do with temperature, and why is that important? So if you imagine that you have a field and you put in the seeds, and then at some point the plants are sticking their heads out of the ground, so the emergence phase, if you have this in a heterogeneous way, so one part of the field is faster than the other part, then you have a competitive situation, because this part of the field will then shadow other parts of the field, things below that will grow slower, the root system will grow slower, and so on and so forth. What's the impact? The impact is, if you have emergence within 4 days compared to within 1 day, you're losing up to 75% of the harvest, 75%. And we're all about food security. So we're working with this machine producer, which can then produce, let's say, create maps out of temperature data, which is basically temperature and moisture is what you need in order to optimize seeding depth, to plant the seeds in exactly that depth, which allows you to have a completely homogeneous emergence. So that is one use case. So you would go on your whatever tractor, machine, go over the field and plant every seed in exactly the right position in terms of depth, in terms of available temperature, energy, available water, so that all the seeds are emerging at the same time.
Yeah.
That is one use case.
And Max, one of his key points is Max is a very humble person. He's talking about one of the leading OEMs for agriculture machines, and we're also talking to that industrial player for the obvious reasons, because we're interested to understand the use cases and how the knowledge transfer will be happening back to you. And they're really excited about you, and you're one of the few companies that have been selected in that innovation program that they're running. It's only, I think, 6 or 7 global companies. You're one of the first Europeans, or even the first European company that made it, which is obviously a great endorsement, and hopefully an interesting commercial path to come involved.
But I mean, it's not only about POCs, right? So we have already secured more than 8.5 million in legally binding contracts. We're north of 100 million in the pipeline. So, and that's for a product which doesn't really exist yet, right? So we're launching the satellite, the first commercial satellite. We had a prototype, first commercial satellite about 4 months from now, 5 months from now. And then things are really getting interesting, because a lot of people on the sideline waiting for what's going to happen next, but it's really going to change how we view our planet in a drastic way. Just to give you maybe a comparison, the change in resolution to what is today possible with European space systems compared to what will be possible in less than a year from now is as if you go from a Game Boy to 4K television. It is massive. It's the change of or the difference between looking at London and telling you, hey, London has 12 degrees today and it's sunny, which is a joke by itself, but it apparently was true also yesterday, to telling you exactly what's the temperature of your house, your neighbor's house, your garden, and so on. So we will basically create a transparent planet to a certain extent, which allows us to optimize a lot of processes in agriculture, and that's our main focus. That's where we spend most of our energy. But also we see other sectors which could prominently benefit from that. Looking at activity in terms of what's activity in oil refineries? Is there an anomaly in a power plant? What about leakages in underwater pipelines? And all of these things. So suddenly we will have a very good view on the globe in a spectrum which was previously hidden to us, or maybe hidden to those parts of us which are not working for military. Yeah,
and for that very reason, and not just us as investors, and there's a whole bunch of, hopefully very credible investors, I believe, obviously excluding ourselves, but very credible investors.
No, I think you're okay
and
too.
Also, the European Space Agency is a big fan and, heavily supporting you in all directions. So we're looking forward to great things to come, hopefully, as and when the satellite will be operating next spring.
Exactly. So, as I said, launch is happening in a couple of months from now. Obviously, a lot of things can still happen, but we reached a couple of really, really good milestones. We basically just, it's interesting, very, very quick story, anecdote about working with the European Space Agency. For those who've done that already, just last Friday, we have concluded the critical design review, which is usually the time when the design is then freeze and you start manufacturing. On the same day, we had the manufacturing done. So we told the European Space Agency, hey, look, super nice that you endorse us and that you find the design flawless. We've actually already built the satellite. They were slightly pissed, but also grateful that we didn't wait for them, because this was the agreement from the start. But again, right, so it's working quite well, and we're very happy to have them as a supporter in very many different respects. I think it's one of the core business partners, and also because they are on board, we are the de facto data provider of high-resolution thermal data for the European Union for the next 5 years, which is a nice thing to be able to do too.
Very bright spot in deep tech, new space to watch, and hopefully
and nature tech, apparently.
And nature tech as well, and climate tech to some extent.
Yes, no, definitely.
Apparently, Max still has some slots available. He was telling me he had 25 meetings already today, so something's going right.
Anyway, no, things are working quite well.
Thanks for your time.